Beneath the sunlit oceans hides a crushing, lightless world so extreme that humans have barely dared to look. Formed where the Pacific Plate subducts beneath the smaller Mariana Plate, this crescent-shaped trench stretches over 2,500 kilometers through the western Pacific's Ring of Fire. Its lowest point, Challenger Deep, reaches 10,935 meters, colder and darker than any surface desert. Despite pressure exceeding 1,000 atmospheres, amphipods, snailfish, and microbial mats thrive here. Only a handful of manned submersibles have ever reached the bottom, making it humanity's least visited place on Earth. Also called the Mindanao Trench, this feature runs roughly 1,320 kilometers along the Philippine Sea Plate's boundary, reaching depths near 10,540 meters. It formed through subduction of the Philippine Sea Plate beneath the Philippine Mobile Belt, an area riddled with volcanic and seismic activity. The trench's isolation has preserved unique Hadal organisms, many undiscovered. Nearby coastal communities depend on the rich fisheries above, unaware of the alien world lying directly beneath their boats. The Kermadec Trench extends nearly 10,047 meters deep, formed by the Pacific Plate subducting beneath the Australian Plate along New Zealand's northern arc. This active margin produces frequent volcanic eruptions and towering underwater mountains. Hydrothermal vents nourish chemosynthetic ecosystems independent of sunlight entirely. Giant amphipods and unique fish species dominate these depths. Indigenous Maori tradition regards these waters as culturally significant, while scientists study the trench to understand extreme pressure biology and plate boundary behavior. Running along Russia's Kamchatka Peninsula and the Kuril Islands, this trench reaches depths near 10,500 meters where the Pacific Plate subducts beneath the Okhotsk microplate. Constant seismic activity generates powerful earthquakes and destructive tsunamis across the region. Frigid surface waters support rich fisheries, while the trench itself remains icy, dark, and largely unexplored. Its remoteness, harsh climate, and geopolitical sensitivity have kept scientific missions rare, leaving much of this Hadal zone a genuine geographic mystery. The Japan Trench reaches approximately 8,000 meters, formed by the Pacific Plate subducting beneath the Okhotsk Plate off Japan's eastern coast. This subduction zone produced the catastrophic 2011 Tohoku earthquake and tsunami, reshaping global understanding of megathrust hazards. Cold, nutrient-rich currents support abundant fisheries above, while Hadal depths host specialized amphipods and bacteria. Japanese researchers have pioneered deep-sea robotic exploration here, blending scientific curiosity with urgent tsunami preparedness studies for coastal safety. Reaching about 8,376 meters, the Puerto Rico Trench marks the Atlantic Ocean's deepest known point, formed where the North American Plate subducts beneath the Caribbean Plate. This boundary also involves complex strike-slip faulting, unusual for typical trenches. Steep underwater cliffs plunge dramatically toward the abyss, occasionally triggering tsunamis threatening Caribbean coastlines. Warm tropical waters above teem with coral reefs and marine tourism, starkly contrasting the cold, crushing darkness hidden just kilometers beneath vacationing swimmers. The South Sandwich Trench reaches roughly 8,428 meters, formed by the South American Plate subducting beneath the small Sandwich Plate near Antarctica. Freezing temperatures, violent storms, and remote positioning make this one of the most inaccessible trenches globally. Volcanic islands above host penguin colonies and seal populations, while icy waters below remain almost entirely unstudied. Its extreme isolation preserves pristine Hadal ecosystems, offering scientists rare, undisturbed insight into how life adapts beyond human reach. Extending south from the Japan Trench, the Izu-Ogasawara Trench reaches nearly 9,780 meters, formed by continued Pacific Plate subduction beneath the Philippine Sea Plate. This active volcanic arc includes islands like Iwo Jima, still rising from underwater eruptions. Nutrient-rich currents attract migratory whales and seabirds above, contrasting the trench's frozen depths below. Japanese oceanographic institutes use this remote region to study subduction dynamics, volcanic arc formation, and rare Hadal species adapted to permanent darkness. Also called the Peru-Chile Trench, this feature stretches over 5,900 kilometers, reaching depths near 8,065 meters where the Nazca Plate subducts beneath the South American Plate. This active margin generates some of history's largest recorded earthquakes. Cold Humboldt current waters above sustain enormous fisheries, while Hadal depths host specialized amphipods surviving on sinking organic debris. Chilean researchers actively study this trench to improve earthquake prediction along South America's densely populated coast. The Middle America Trench stretches roughly 2,800 kilometers along Mexico and Central America, reaching depths near 6,662 meters where the Cocos Plate subducts beneath the North American and Caribbean plates. This subduction fuels Central America's active volcanic chain and frequent earthquakes. Warm tropical surface waters support diverse marine tourism, while Hadal depths remain cold and largely unmapped. Scientists monitor this trench closely, since its seismic activity poses ongoing risk to nearby coastal populations. The Sunda Trench, often called the Java Trench, reaches approximately 7,290 meters where the Indo-Australian Plate subducts beneath the Sunda Plate. This subduction zone produced the devastating 2004 Indian Ocean tsunami, killing hundreds of thousands across coastal nations. Warm equatorial waters above support extraordinary marine biodiversity, including coral triangles, while Hadal depths remain poorly explored. Indonesian and international scientists now monitor this trench intensely, using seismic networks to provide early tsunami warnings regionally. The Diamantina Trench, or fracture zone, reaches depths near 8,047 meters southwest of Australia, formed by ancient continental rifting between Australia and Antarctica roughly 100 million years ago. Unlike subduction trenches, this feature resulted from tectonic plates pulling apart. Cold southern ocean currents circulate above, supporting krill and migratory whale populations. Its remote southern location keeps exploration minimal, making the Diamantina one of the most mysterious, historically overlooked deep-sea features on Earth. The Romanche Trench reaches roughly 7,758 meters near the equator in the Atlantic Ocean, formed along a transform fault connecting the mid-Atlantic ridge offset segments. Unlike typical subduction trenches, this feature results from plates sliding horizontally past each other. Warm equatorial currents above support West African fisheries, while its narrow, steep-walled depths remain largely unexplored. Geologists value this trench for revealing rare transform boundary processes, offering insight into complex mid-ocean ridge tectonics. The Hellenic Trench reaches roughly 5,267 meters, the Mediterranean Sea's deepest point, formed where the African plate subducts beneath the Aegean microplate south of Crete. This active boundary produces frequent earthquakes and occasional tsunamis threatening Greek islands. Warm Mediterranean waters above support tourism and fisheries, while cold depths below remain surprisingly understudied compared to Pacific trenches. Researchers consider this trench crucial for understanding seismic risk across densely populated southern European coastlines. The Aleutian Trench stretches over 3,200 kilometers along Alaska's volcanic arc, reaching depths near 7,822 meters where the Pacific Plate subducts beneath the North American Plate. This zone produced the powerful 1964 Alaska earthquake, among history's strongest recorded. Cold, nutrient-rich waters above support enormous fisheries and diverse wildlife. Hadal depths remain frigid and largely unexplored. Scientists continuously monitor this trench, since its seismic activity poses ongoing tsunami risks across the entire Pacific Basin. Rather than a surface trench, the Indian Ocean Geoid low sits south of Sri Lanka, marking the planet's largest gravitational dip. Scientists believe it formed from a dense, ancient slab of the long-vanished Tessis Ocean sinking deep into Earth's mantle millions of years ago. This anomaly lowers sea level here by over 100 meters. Though invisible to sailors above, it reveals how deep planetary forces beneath Sri Lankan waters still shape ocean surfaces today. From Mariana to Sri Lanka, these crushing depths remind us how much of our planet remains unexplored. Subscribe for more hidden wonders.